to trends in physical and chemical properties of elements. Trends just means periodicity, that is repetition, that is something which happens like a pattern. Noble gases in your periodic table. So you know that at the end of this, after 10 elements, there comes a noble gas. And again after 10 elements, again there is a noble gas over there. So that's called a pattern. You have patterns like this, don't you? In your aptitude tests, they give you a triangle, they give you a circle, or they give 3 circles, and then again they have a triangle, and then they ask you to fill up the blanks and complete the pattern. What do? You put 3 more circles, and then you put a triangle, and again you put 3 more circles. So that's a pattern. So the same way, you have patterns in your physical and chemical properties. So what are these patterns? We will discuss these periodicity. We call it periodicity. We don't use the word patterns. We call it periodicity, and periodicity in physical properties is what we're going to discuss now. So what is physical properties? You say a man is so tall, or that lady is so fat. So those are physical properties of people. So when you take elements, what are the physical properties that you can get over there? First thing is, maybe you can tell the size of an atom. So size of an atom, when you go to, what is it? It is the radius of an atom. So since we consider that an atom is almost spherical in shape, so definitely that means radius is going to come inside. So we have atomic radius, we have radius of an ion, ionic radius, we have something called ionization enthalpy, electron gain enthalpy, electronegativity. So we will be discussing these topics over here now. What is atomic radius? The atomic radius is what? Like now you have a nucleus. This is the nucleus of an atom. And say you have, this is one orbit. It is having 2 electrons and one more subshell. It's having, say, 6 electrons. Okay. So atomic radius is the distance between this and this. Is that not right? When we say radius of a circle, it means from center to circumference. So any direction you go, is the radius. Likewise with your atom, from the center to the end is, to the last electron is the atomic radius. But we define it, we say it in a different way. Between the center of the, we cannot take an atom by itself like this, because we know they do not exist like this. If we say one atom of an element, we will not be able to compare it and get the correct thing. So we go on to diatomic particles, that is 2 atoms of the same element are called diatomic. Okay, so we take for example the atom of an oxygen. Okay, so what is the atom of an oxygen? You have the nucleus, yeah, and you have one subshell with 2 electrons, yeah, you're having another subshell. Now it has 8 electrons, oxygen, okay, it has 8 electrons. So you have 1, 2, 3, 4, 5, 6. Okay. Now it's diatomic. So you have one more atom of an oxygen. Okay. You're having the first subshell with 2 electrons, and again you have we have one more orbital which comes like this. Yeah. So you have again 1, 2, 3, 4. This one's electron comes here and then here. Can you see? This one is belonging to this. So you have how many? 2 oxygen. I know it appears a little unequal, but please bear with me. You have 1, 2, 3, 4, 5, 6, 7, 8 belonging to this atom, and you have 1, 2, 3, 4, 5, 6 and 7 and 8 belonging to this atom. So this is a diatomic particle. So what we do is we measure the distance between their nucleuses. That is, it's called a homonuclear molecule. Homonuclear diatomic molecule. Homonuclear, 2 nucleuses, 2 atoms, diatomic. You measure the distances between the centers of their nucleus and you do a half and you get the radius of an oxygen atom. Is that clear? So now, with this connection, what is its connection to your periodic table? Is that the radius of an atom decreases as it goes down the periodic table like this. So from 1A, the atomic radius decreases as it goes down the table. When you come like this, so down the group it decreases, but down the period it decreases down the group. But what does it do here? It increases down the period. So they both are different. So when you come down like this so when you are coming down the periodic table, down the periods, the atom size or atomic radii increases, and while you are going down the groups horizontally, it decreases. So it increases and decreases, or decreases and increases. So now we go on to another related topic which is related to atomic radius. It's called atomic size. Your size of an atom. The size of an atom is dependent on certain factors. That is the number of protons which are present in that nucleus of that atom, the number of energy levels holding your electrons, that is number of orbitals that you have, and the number of electrons that are there between the nucleus and the outermost electron orbital. Okay, so how do you decide what's the atomic size? Now here we are not going to calculate the atomic size, but we are going to give reasons as to why certain atoms are smaller and certain atoms are bigger. So now just let's look at the reasons which affect the size of an atom. So here I will be taking the sodium atom. Okay, it has an electronic configuration of 1s2, 2s2, 2p6 and 3s1. So nucleus, and then we have the first orbital s2 containing 2 electrons. Yeah, you can see your 2 electrons. I am almost drawing it on the size of the. Then you have 1 more and 2 more electrons. Energy levels. So these energy levels have to go in order only. Okay. Then you have the P, 2p, which is having 6 electrons. Then you have the next energy level, which is an s orbital, which has only one electron. So we know that s orbital can contain two electrons, but here it's having only one electron. As we were going through atomic size, now here I have drawn the sodium atom with its electrons. We see that the last orbital, s orbital, has only one electron, so it can accommodate one electron of some other element. Now here, what are other factors that affect atomic size? The number of electrons between the nucleus and its outermost atom. So how many electrons exist between these two? So how many electrons are there in the three orbitals which are inside? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 electrons. These are called core electrons. This is the outermost electron and the rest of it is called the core electron. So core electrons give us a force of attraction. They decide whether this outermost electron remains with the element or goes into another element, goes away to another element or binds with it. So what are the factors that affect atomic size? The number of protons inside the nucleus. Okay, so one is number of protons. One more factor is the number of energy levels holding the electron. So how many number of energy levels are there here? There are 4 number of energy levels. Yeah, in this sodium atom there are how many number of energy levels are there, and the number of electrons that lie between the nucleus and outermost electron. So these are the 3 factors that affect atomic size. One more thing that we have to see here is something called the shielding effect. What is this shielding effect? These electrons, which we call core electrons, exert a force of attraction on this last outermost electron. Here it is only one. Sometimes you may have 2, 3, 4, 5, 6, depending upon the orbital in which it's placed. So the core electrons exert a force of attraction onto this electron. That is called shielding effect. The weakening of that force is called shielding effect. Now we have to understand, when does that force weaken? Now when all these electrons are less, there is the electrostatic force between the nucleus. Now these are electrons. We already know that the reason that they are surrounding this nucleus is because of the force of the protons. That is, the attraction between the protons and the electrons is what is making them go around the nucleus. Now as the number of orbitals increases, the electrons go further and further away from the nucleus. So will you not assume that the force of attraction gets reduced, weakens? So then what happens to the electrons which come in the outermost orbital? They tend to move away. Because of this shielding force, they tend to move away. So that does affect the size of the atom. Now this shielding force, I will show it with another orbit, with another element. You have the element cesium. Cesium comes next in the group of sodium. Okay, so sodium is on top and cesium comes below. I will just write its electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6 and 6s1. They end with the same last orbital. Now, to just go and draw this, I know this is going to turn out to be a really big one, but let's try to draw it. We have the nucleus. I will just draw the nucleus here. Yeah, I'll just draw a tiny nucleus. Then you have first 1s2 has 2 electrons. So now compare this and sodium. Can you even count the number of electrons that are there between the nucleus and this 6s1? There are so many electrons and there are so many orbitals. So what kind of shielding effect will be there in this cesium? Cesium will have a very weak attractive force compared to sodium. What is ionic radius? Ionic radius, see, you already know that ions are of two types, cations and anions. So again, how is a cation formed? When you lose an electron from an atom, when you remove it from an atom, a cation is formed. And when you add an electron to an atom, an anion is formed. So to understand what is ionic radius, we first need to know cation is removal of electron and anion is gaining of electron. Yeah. So when this happens, you get a cation and an anion. What is the ionic radius in this? It is the distance between these two. So what is the ionic radius? The ionic radius is the distance between the cation and anion in ionic crystals. A cation is smaller in size than the parent atom, because why? It's losing an electron, whereas an anion is bigger in size than its parent atom because it's gaining an electron. Now we go on to ionic energy. The energy between this cation and anion is called ionic energy. So the greater the distance, the lesser will be the energy. The lesser the distance, its energy is more. Ionization enthalpy is the energy which is required to remove an electron from a gaseous atom. So you have to remove an electron from its gaseous atom. That is, the atom has to be in what form? Gaseous form. Why not a liquid or a solid? Because when it is a liquid or a solid, there are other energies acting on this atom. in the gaseous form, it is in its most free state. So when you can remove an electron from an atom in its gaseous state, that energy required to do this work is called ionization enthalpy, considered to be one amount when you have to take out the first electron, okay, and goes on increasing more when you have to take its second electron, and so on. Electron gain enthalpy means the energy required gain an electron. So first we saw ionic enthalpy. What is ionic enthalpy is? The ionization enthalpy is the energy required to remove an electron. Electron gain enthalpy, as the name says, is the energy required to gain an electron into an atom in its gaseous state again. So what are you doing? You are gaining an electron again in its gaseous state only. Now when you gain an electron, what will happen to that atom? It becomes bigger. Okay? So you have an idea of how easily to add an electron. What is electronegativity? Electronegativity is the ability of an electron, of an atom, which is in a chemical compound, to attract shared electrons. So you have a compound. Definitely a compound is made out of two different kind of elements. So you have two elements in a compound. Now the ability of this compound to attract shared electrons is called electronegativity. This electronegativity is not a measured, cannot be calculated. Okay, it depends upon the compound, it depends upon from where the shared electrons are being taken. So it cannot be said that it is this much or this much, but we do have measuring implements which we use to measure this electronegativity. Some of them are the Pauling scale. The one of it is this Pauling scale, which was invented by an American scientist named Linus Pauling. So here we've seen physical periodicity, some of the physical trends which come in atoms, elements.
Thank you for watching. Visit us at needbook.in.